So now I discuss about the topic called as the Einstein's coefficient. Actually, this laser was actually discovered, and laser and its theory was actually discovered. The theory of laser was discovered by Albert Einstein. Okay, so based on him, some theory has been done, and some coefficient has been named after him. Actually, this laser is a probabilistic process. Uh, the the number of atoms in laser, you have got three processes: absorption, spontaneous emission, and stimulated emission. So the number of atoms which will undergo spontaneous emission, number of atoms which will undergo stimulated emission, number of atoms which will undergo absorption is you cannot definitely say about that. There is a probability that this much atom will do, this much atom will not do. You cannot tell it definitely. So I have drawn this thing here. This is the active medium of the laser, and here there are N1 atoms in the ground state and N2 atoms in the excited state. So and there are also photons here. Since laser is happening, there has to be photons. Photons are coming and hitting the mirror here and then coming back. Okay, so that is why so I have written here suppose N1 atoms are there in the state 1 and N2 atoms are there in state 2. Suppose P12 is the now another thing is that since there are photons here, there will be definite electromagnetic energy. So U nu is the energy density of radiation in this cavity. Okay, U nu is the energy density of radiation, that is energy, electromagnetic energy per unit volume. Okay, now since I told that it is probabilistic process, so suppose P12 is the probability of absorption. Okay, that is transition from 1 to 2. Now P12 will be proportional to the energy density of radiation, because that is it will be proportional to the number of photons which are hitting the atoms in the ground state. So more now number of photons will be there, more absorption will happen. So that is why P12 will be proportional to U nu. So there will be a proportionality constant which is written as B12. Now B12 is called as the Einstein's coefficient of absorption. Okay, the name given to this is the Einstein's coefficient of absorption, B12. Similarly, now this is the probability. The number of atoms which will the number of atoms which will absorb the energy and go to the excited state will be what? You have to just multiply N1 with P12. So I have done that. N1 into P12 is equal to N1 into B12 into U nu. Okay. Now comes the spontaneous emission. Now that is what P21 is the probability of spontaneous emission. Okay. Now P21 will be independent of U nu. Okay. P21 will be independent of U nu. Now P21 will not depend, because it happens automatically, spontaneously. So P21 is written as A21. A21 is called as the Einstein's coefficient of spontaneous emission. Okay, so number of atoms which will undergo spontaneous emission will be what? N2 into P21. So that is equal to N2 into A21. Now P21 prime is the probability of stimulated emission. Okay. Now P21 prime will definitely depend on the number of photons, because photons will come and hit the atoms in the metastable state, and they will then come down. Okay, so P21 prime is the probability of stimulated emission. Now P21 prime will be proportional to U nu. So P21 prime will be equal to B21 into U nu, or B21 is called as the B21 is the Einstein's coefficient of stimulated emission. Einstein's coefficient of stimulated emission. So number of atoms which will undergo stimulated emission will be what? There, how many atoms are there in state 2? N2. So N2 into P21 prime, that will be equal to N2 into A21 into N2 into A21 into U nu. Okay. Now this is the equilibrium condition, that is energy conservation principle is maintained here. Now if that is maintained, amount of emission will be equal to the amount of absorption. So from that absorption, what you will get? N1 into P12. Number of atoms which are absorbed is N1 into P12, and number of atoms which are undergoing spontaneous emission is N2 P21. Number of atoms which are undergoing stimulated emission is N2 into P21 prime. So if you expand this, it will be N1 into B12 into U nu is equal to N2 into A21 plus N2 into B21 into U nu. Now if you take U nu common, this will come as N1 into B12 minus N2 into B21. That will be equal to N2 into A21. Okay, so from U nu, what will you get? N2 into A21 by N1 into B12 minus N2 into B21. Okay, now if you again now let me come here. That is, according to Planck's law of electromagnetic radiation, the energy density of radiation is U nu is equal to 8 pi h nu cube by c cube within bracket e to the power h nu by kt minus 1. Okay, so this equation and this equation must be similar equation. Now in this equation you see that here there is a minus 1. Okay, e to the power h nu by kt minus 1. So this equation also you have to write it in that form. So to write it in that form, here this term has to be 1. So you divide both the numerator and denominator by B21. Okay, so what will be that? A21 by B21 and this will be N1 by N2, B12 by B21 minus 1. Okay, now you compare this equation. That is, this is say equation 1 and this is say equation 2. Okay, so this is cut. Comparing equation 1 and 2, what will be A21 by B21? A21 by B21 will be 8 pi h nu cube by c cube. That will be A21 B21, and B12 by B12 by B21. What will be that? That will be equal to 1. Okay, because N1 by N2 is what? N1 by N2, you can write it like this: A21 by B21 by B12 by B21 into e to the power of h nu by kt minus 1. So N1 by N2 is actually e to the power h nu by kt only. So coefficient of e to the power h nu by kt is what? B12 by B21. The coefficient of e to the power h nu by kt is what here? 1. So B12 by B21 is equal to 1. So these are the Einstein's coefficients. And these are the values of the Einstein's coefficients.